Hello everyone, my name is Ketan Sharma. How you guys are doing? So I hope you all are very great. And today I'm going to demonstrate something to you guys, which I think you will find pretty interesting if you are into this stuff. And also happy Diwali to everyone out there seeing this video. I hope you have a great festive season and happy holidays. Now, let's see what we are going to do is today we are going to see an example of trade analysis. All the buying and selling of the stocks you see, how it happens very fast. Like in few minutes or in few seconds, we have to update and get the analysis of all that data, how many trades have been made and how many sales have been made. How does that happen? And how what infrastructure and what we can say what system design is followed that I'm going to show you here. It is a very basic data pipeline. Okay, so here is I have given a trade. What does a trade have? It has, I don't know much about trading, so I don't know what these terms mean. So one trade can have an, I guess it is called opening value. It has a closing value, all-time high, all-time low, the time it was done at, time and date, and the index value. Index value is basically a serial value that is given to our data. This is basically our payload, you can say JSON, on which the data would be sent, on which data is sent from the front end to the back end to the API gateway. Okay, now the stars of our system design here: Apache Kafka and Apache Flink. Okay, so what is Apache Kafka? Apache Kafka is a queue. Apache Kafka is a queue on which our this JSON data is sent. Why do we use queue? We use queue so that we can keep our data aligned. What does that mean? So let me show you. Suppose basically what happens is in real time, a lot of data is generated. Okay, very fast. And in to keep it aligned, like the queue uses FIFO, first in first out. Okay, so in order to keep them in a queue so that everything goes in a buffered way, that is why we use queue. And that is not the only use of Kafka queue. It is basically a message broker service also, which transfers messages to other services. Suppose on AWS, we have to transfer one message to basically a Lambda instance, a Lambda function. We can use a message broker. It also works as a message broker. So you know why a Kafka queue is used. It is for real-time streaming of data. Okay, we usually use Amazon Kinesis for that on AWS. Okay, now let's move on to what is Apache Flink. Now we have producer. What is a producer? My laptop can be a producer. My mobile phone can be a producer, which produces this kind of data. Okay, and then what is Kafka is doing? Kafka is structuring the data in a queue. What is Apache Flink is doing? Flink performs the stream processing. If Apache Kafka is responsible for real-time streaming, Apache Flink, or you can also use Apache Spark, are responsible for stream processing. What is stream processing is all this data that you have, you might want to do some processing on it. For example, calculate the average of closing value of a trade, all-time high, all-time low value of a trade, average value, top three values, something like that. You can do that using Apache Kafka, sorry, Apache Flink. And what in this example we are going to use is we are going to create a time window. For example, right now it is yeah, it is 2:24. So 220 for 10 seconds to 220 for 20 seconds. A 10-second window we are going to give to our Apache Flink, and we are going to check what is the sum of all the closing values of all the trades that have passed through this small window. Now it is a very low latency operation. Okay, in 10 seconds, right now I will be sending only five to six trades, but in 10 seconds, about thousands of trades go through one Kafka queue into one Apache Flink uh, server. Okay, so scaling has to be done a lot in real-time scenarios. Okay, but it is a small example, so I'll give you a very cheap exit, like a very low, like a very, you can say, not a very high computation example, a very low computation example. How do we perform this? What data structure that we use? You might have learned about windows. As I said, we are going to implement a window, but there are different windows in Apache Flink. We have a tumbling window, we have a sliding window. Now, let me tell you what is a tumbling window and what is a sliding window. Suppose we have a time frame 10, 20, 30, 40, and 50. Now, let me show you what's a tumbling window. This is my window. Now, what is going to happen is it is going to tumble. Like, it is going to tumble from here to here. And at some point, this is basically the interval, the offset that we get. Once a 10-second offset, and this window will go from here to here to here. Okay, try to understand like this. This is my window from 0th to 10th time frame. Okay, and then it tumbles over to the next time frame. Okay, so either it can have no offset or it can have a offset, an offset. So this is basically the offset of 10 seconds. You can also have it like if we move from 20, we can grow from 20 to 40 also. It is up to our configuration. What is a sliding window? A sliding window, it is going this way. This is our tumbling window. A sliding window is we start from 10 to 20. Okay, then we slide to 10 to 30. Our offsets can also be, greater. In sliding window also, I've used 10. I use 10 to go from 0 to 10, and I can also go from 0 to 20 also. Like 0, I am at 10 right now, I can go to 30 to 50. So this could be my offset. This is the sliding window offset, and this is the tumbling window offset. So I'm going to use the tumbling window here. Okay, so this is what you have learned, and what I'm going to send is I'm going to send 5 trades in 10 seconds, which means every 2 seconds one trade will go, and each trade is of some 8k value, which means we would have around 40k, the aggregate value in 10-second window. Okay, so basically, to give you an overview, my laptop will produce the data. Apache Kafka, which I have hosted on AWS, that will send data to Apache Flink, which is on my computer again, and I will send that data back to AWS on the same Apache Kafka streaming queue. Okay, but different topic. I will talk about the topic also. So suppose and now right now I have a topic named trade events. My producer is the publisher to this topic, which belongs to this Kafka queue. Okay, and now I have another consumer, which is Apache Flink, which will consume from this topic. It is as simple as that. And then this Apache Kafka has another topic, top K trades. So my Apache Flink will send the data to this another topic. And further, it can also have another consumer. All right. So we can send it to this Kafka topic also, or to Postgres also, a database, basically. Okay, it is up to you where you want to send your data back to. Okay, now now that we know that our producer will send to trade events, our Flink which fetch from trade events and produce the data back to top K trades, there is one uh, thing that I would like to clear that I will show you while doing the demo. So let's do the demo. Basically, let me tell you how I've hosted the Apache Kafka. I've basically created an EC2 instance inside a VPC with a subnet and an internet gateway connected to it. It is a very simple uh, infrastructure. Okay, I have it in AP South 1A. All right. Now, let me show you what is going to happen. Okay, so this is my window. Here the zookeeper. What is zookeeper? Zookeeper is basically which monitors all the stuff that happens on a Kafka cluster. For example, let me show you. Uh, yeah, Kafka architecture. So this is the Kafka architecture. We have producer, we have different consumer, and this is one consumer group. I will talk about this consumer group. We can make one consumer group and have different consumer onto it also, or we can also have a single consumer directly fetching data from the Kafka cluster. Zookeeper looks after everything that is happening, kind of a monitoring service. And we do have different producers. We do not have producer groups, we have consumer groups. Okay, so now let me show you what is happening. Here is the zookeeper running. Okay, and here is my Kafka running, and here I will have the consumer which would be monitoring data that goes from Kafka into the Apache Flink. Let me show you. Okay, so in order to monitor this this phase, I will have one consumer which would be pointing to this topic, and this Apache Flink is also pointing to this topic, which means that they belong to the same group, right? So this consumer and this Apache Flink are both trying to fetch data from the same topic. So they are both in a same group. Now let me show you what is that group. So that group is this trade events group. Okay, in this group we have our Apache Kafka, which is this Apache Flink job, and this terminal also. So let me show you now this, and on this terminal I will have the data from Apache Flink. Okay, so Apache Flink is sending data to top K trades as I've shown you in the diagram. Okay, so let's go again for overview of all the terminals. Here is the zookeeper, here is the Kafka, here is the consumer which is monitoring the data between Apache Kafka and Apache Flink, and this is the top K trades terminal which would be fetching data from the Apache Flink. Now let's begin with our demonstration. Okay, now we have our producer. I'm producing this data which has date, open, high, open value, high value, low value, and close value. Okay, and this is sending data to this IP on which my Kafka is uh, hosted. Now, this is the trade events, the topic to which my uh, Apache Kafka is going to send the data into. Okay, now let's run it. I've started running it, and probably here, if I start my trade events consumer, I will start seeing some data. As you can see, I have started to see it. We have in index 8, 9 coming up. All right. And now I'm going to start my Apache Flink job also. Now, as soon as I start my Apache Flink job here, I will start to see the top K trades, the aggregated value of all my trades. See, first I have 41,000, around 40K, okay, which is for between the window 3530 to 3540. Then I have again 41,000 something value from 40 to 50. So what is actually happening is, as you can see, that every for every 10 second, okay, every 10 second, my 5 trades are being sent. All right. And here, every 5 seconds, a output is being produced. Okay, which is giving me the cumulative of all the 5 trades that go into this 10-second tumbling window. All right, so as you can see that, suppose these 5 trades are being sent, which has value of 8298, 8300, 8298, 8299, 8297, and this would be having one aggregated value over here. Okay, so every aggregated value is around 41,000 because all of my trades are going around these values only. All right, so this was basically how real-time streaming and real-time operations are done, okay, on these applications. Basically, Kafka is used to streamline the data, and Apache Flink, or you can also use Apache Spark, is used to do some operation on that data. Okay, here we can see some tables. We have created a table which have all this matrix. So pretty much, yeah, this is how it's happening. And right now I have my Kafka stored on a EC2 server because I thought it would be a great experience also to serve some data on cloud, because it is very hard to deploy stuff on cloud until unless you're using containerization and Kubernetes. Okay, so I'm done with my demonstration here, and again you can see, so what I said was that these both belong to one group, which was trade events group. Okay, and this was the top K trades. This was terminal 4, this was terminal 3. Okay, what I was talking, this was terminal 3, this was terminal 4 here. This is terminal 3, monitoring the data between Apache Kafka and Apache Flink. This is the terminal 4, getting the output out of the Apache Flink. This can also, as you can see, it is just a schema. It can also go into a key value database or Postgres also. All right. So this much about this demonstration. Why I did it, I just find it pretty interesting to show that how this stuff happens behind the back in the back end. So I hope you all like it, and do give it a like. Happy holidays, everyone. Bye bye.